Welcome to my channel, STEM Cafe. Here we handle everything science, technology, engineering, mathematics for ease in comprehension, assimilation, fun, entertainment, and ease. Today we are dealing with indices, surds, and logarithms. These are very basic topics for scientists, for engineering, or engineers, engineering students or engineers, mathematicians. But very important to understand. And here it's not just to treat it. We want to make it fun, and we look at ease, fast ways of handling the topics or any question that come out under these topics, so that anybody that sits for examination, either multiple choice exams or written exams, will get everything perfectly well. Let's start. In indices, we talk about power. We talk about power, raised to power this, raised to power that. How do you arrive at that? Let's look at something. When we bring in two things together, we say add. Like when we say we have 3 plus 3, that is addition. Now, when we add in multiple times, it becomes the same number. When we add them together, we have multiplication. Let's look at this. 3 plus 3 is equal to 2 times 3. You can see this time, this addition now later gets to multiplication. 4 plus 4 plus 4. That is why we have 4 in 3 times. We have 3 times 4 or 4 times 3. In the same way, when we multiply the same number over and over, we have power. Let's look at this. 3 times 3 is equal to 9. But when we have it, we can also state it like this. 3 times 3 is equal to 3 raised to power 2. That is, we multiply 3 in 2 places. Let's look at this one also. When we have 4 times 4 times 4, we say we have 4 raised to power 3. In multiplication, you can say 3 times 4 is also equal to 4 times 3. But in this place, you cannot say 3 raised to power 2 is this. Or, those are the basic facts. So, this is where the whole thing is. Nothing again. We are demystifying that. Anything you have that makes it look hard, nothing again. Once you know this, you have already gotten everything in indices, surds, and logarithms. Now let's look at some things that they gather together, and we call it laws of indices. Let's start with one. Let's say we have 3 raised to power 3. It will be 3 times 3 times 3. Let's see, 3 raised to power 4 is going to be 3 times 3 times 3 times 3. Now, let's say we have 3 raised to power 3 times 3 raised to power 4. It's going to be 3 times 3 times 3 times 3 times 3 times 3 times 3. And what does that give us? 3 times 3 times 3 times 3 times 3 times 3 times 3, which is 3 raised to power 7. And this leads us to the first law. That is, when we have number x raised to power a times x raised to power b, it's going to give us x raised to power a plus b. X raised to power a plus b. That's the first one. Let's look at another one. Let's say we have 3 raised to power 7 divided by 3 raised to power 4. We are going to have 3 times 3 over 3 times 3 times 3 times 3. So we have this. So at the end of the day, we have 3 raised to power 3. So this gives us the next rule. That is, when we have x raised to power a divided by x raised to power b, is going to be x raised to power a minus b. That's the second one. So for addition, for multiplication, we have addition of the powers. For division, we have subtraction of the powers. Once you have understood that, raised to power means multiplied in several places. Every other thing becomes simpler. Now, from the first and second rule, we can also say something like this. When we have 3 raised to power 3 divided by 3 raised to power 3, we all know that will give us 1. And which will be equal to 3 raised to power 3 minus 3, which is 3 raised to power 0. 3 raised to power 3 over 3 raised to power 3 is equal to 1. So, and this one will give us 3 raised to power 3 3 raised to power 0. So what we are saying in essence is this: any number raised to power 0, any number raised to power 0 is equal to 1. That is, x raised to power 0 is equal to 1. X raised to power 0 is equal to 1. So we have x raised to power 0 is equal to 1. So let's make this one the third one. The third one. So from this, let's look at another one. Raised to power 4 over 3 raised to power 3. That will be 3 times 3 times 3 times 3 over 3 times 3 times 3. Which is equal to 3 raised to power 4 minus 3. 3 raised to power 1. So if you look at it, any number raised to power 1 equals to that number. Therefore, x raised to power 1 is equal to x. Let's make that one the fourth. So you can see from the first and second, we are deriving another one. Let's look at another one here. We have this number 2 times 2 times 2 equals to 8. In essence, it means that 2 raised to power 3 is equal to 8. Therefore, let's divide the powers by, yes, 2 raised to power 3 is equal to 8 raised to power 1. So 2 raised to power 3 over 3 is equal to 8 raised to power 1 over 3. So 2 raised to power 1 is equal to 8 raised to power 1 over 3. So what this one has shown us is this: that when any number is raised to the power of inverse of n or reciprocal of n, this is what it means. So when you have anything like this is what it means: x raised to power 1 over n equals to n roots of x. So let's make this one the fifth. These are things that you know, but you just have to put it down like this. Now let's look at another one. Let's say we have 3 raised to power 2. Now let's raise this one again to power 2. What does that give us? This one is 9 raised to power 2. And this at the same time is 3 raised to power 2 times 2. So which is 3 raised to power 4. So in essence, when we have x raised to power n, and then this one again is raised to another power n, it means x raised to power n. I think this will be the sixth. And what again, if we have x raised to power n, and then we now have it raised to power 1 over n, as from the fifth rule, this is what we are going to have: x raised to power n over n, which is nth root of x raised to power n. Let's make that one the seventh. This one I want to bring in now. Confuse beginners, really, with roots, with this one. When you have x raised to power, okay, let's say 1 over x. 1 over x. What does that show us? It means that x raised to power 0 minus 1. Please, you remember the second rule. That is when we have x raised to power a divided by x raised to power b is going to be x raised to power a minus b. So in this instance, 1 equals to x raised to power 0 over x is 1 over x, which is x raised to power 0 minus 1. I'm trying to derive to achieve something. So this is x raised to power minus 1. Therefore, 1 over x equals to x raised to power minus 1. That is what that means. So when we have 1 over x raised to power n, is going to be x raised to power 0 over x raised to power n, which is x raised to power 0 minus n. X raised to power minus n. Therefore, when you see any expression like this, x raised to power minus a is going to be 1 over x raised to power a. So this one, you must be able to differentiate this one from, that is, x raised to power 1 over x raised to power a is not the same thing as x raised to power 1 over a. Please. So this is the, I think this is the eighth rule. Now that we are equipped with all of this, we can handle any question under indices. Now let's look at this question. Please don't be intimidated by this if you are new to the topic. Just take it one by one. For that purpose, let's do it one by one. 16 over 81 raised to power 1 over 4. The first step is to break it down into the um, factors. 16 is equal to 2 raised to power 4. 81 is equal to 3 raised to power 4. And that will give us 2 over 3 raised to power 4. You can see. Very easy to handle. We multiply this power by this power. By this power. So we have this 2 over 3. For this one we have 9 over 16. And this will give us 3 squared over 4 squared. Okay, 9 over 16 raised to power minus 2. Okay. Minus half, sorry. So we have 9 over 16 raised to power minus half. So we have 3 squared over 4 squared. And that gives us 3 over 4 all squared times minus half. And this one is giving us 3 over 4 raised to power minus 1. And from the rule, we know that this is 1 over 3 over 4, which is equal to 4 over 3. And this one shows 16 over 81 raised to power 1 over 4 divided by 9 over 16 raised to power minus half is equal to 2 over 3 times 4 over 3, 8 over 9. So, if you are new, this is how you have it. But if you have been used to it, you can do it straight and get your answer in one straight line. Now, if you're a veteran, yes, you can do it at once. But if you are new, let's take it one by one. This one, we will convert it to powers of 5 because 5 is the factor of this one. So we have 5 squared into minus half times 3 cubed 1 over 3 plus this one is 11 squared times minus half times this one is 5 raised to power 4 times minus 1 over 4. So let's look at what will come out of this. This one will come, this one, and this one. So we have 1 over 5 times 3 plus 1 over 11 times 1 over 5. So this one gives us 3 over 5 plus 1 over 11 times 1 over 5. I want to make it easy for myself, so I make it like this: 1 over 5 into 3 plus 1 over 11. And this gives me 33. So 34 over 11 times 1 over 5, which is 34 over 55. So that's what it gives me. It gives me 34 over 55. So in this, we need to just learn factorization technique. That's all. We have 3 raised to power n minus 3 raised to power n minus 1 over 3 times 3 raised to power n minus 27 times 3 raised to power n minus 1. Now, if you look at this, above we have 3 raised to power n, 3 raised times, okay, let's make it 3 times 3 raised to power n minus 1 minus 3 raised to power n minus 1 over, we have this one to be 3 times 3 raised to power n minus 3 raised to power 3 times 3 raised to power n minus 1. You can see how it panned out. This one is going to be 3 raised to power n minus 1 into 3 minus 1. Now let's look at this. This one is going to be 3 raised to power n plus 1 minus 3 raised to power n minus 1 plus 3. You can see how simple it comes out now. It's going to be 3 raised to power n minus 1 into 2. This one gives us, so it is going to be 3 raised to power n plus 1 minus 3 raised to power n plus 2, which gives me 3 raised to power n minus 1 into 2 over 3 raised to power n plus 1 into 1 minus 3, which gives me 3 raised to power n minus 1 into 2 over 3 raised to power n plus 1 into minus 2. So, if you look at this, it's going to give me this one, and this one is going to give minus 1. Minus 1 into 3 raised to power n minus 1 minus n minus 1, which is equal to minus 1 times 3 raised to power minus 2 minus 1 over 9. That's the answer. Very simple and straightforward. Now we have this question. 2 over 3 raised to power n. So 3 raised to power 4. 3 over 4 raised to power n, sorry. Equals to 256 over 729. Find m and n. So we have this. 2 over 3 raised to power n into 3 over 2 raised to power 2 raised to power n is equal to what? This one is 2. This one is 2 raised to power 8. And this one is equal to, let me see. And this one is also equal to 3 raised to power 6. That's 27 times 27. And this one. So from there, we can still move forward and say, this one is 2 raised to power n over 3 raised to power n times 3 raised to power n over 2 raised to power 2n is equal to 2 raised to power 8 over 3 raised to power 6. If you look at this very well, the ones below are negative. They have negative power. So if we do it like this, you can say 2 raised to power n minus 2n times 3 raised to power n minus n is equal to 2 raised to power 8 times 3 raised to power minus 6. Let's equate the powers. Let's equate the powers. And how do we do that? The power of 2 is equal to this. The powers of 3 will be equal to this. Therefore, n minus 2n will be equal to 8. N minus n will be equal to minus 6. So if we add, let's call this one 1, let's call this one 2. So adding 1 and 2. Adding, so please look at it. Adding 1 and 2. So when we add this one, it becomes 0. Minus n will become to 2. So n equals to minus 2. To find n, you can see that minus 2 minus n is equal to minus 6. So minus n is equal to minus 6 plus 2, which is minus 4. Minus 4. So n is equal to 4. And you can test it. 2 raised to power 4 times 4 and then 4 raised to power minus 2. You'll see what it will give you. So that is what we have gotten the answers for this question. Let's do one more. Now we have a question. A squared 2 raised to power minus 3 times c all raised to power 3 over 4 divided by a raised to power minus 1 3 raised to power 4 c raised to power 5 equals to a raised to power minus b b raised to power q c raised to power r. We are now asked find p plus 2q. What do we do? Straightforward. We just go a raised to power 2 times 3 over 4 minus 1. That's what we have here. What does that give us? A raised to power 3 over 2 plus 1. 5, a raised to power 5 over 2. That's our minus p. So, p is equal to minus 5 over 2. Now for our q, we have b raised to power minus 3 times 3 over 4 minus 4. You can see the power. So it's going to give us b raised to power minus 9 over 4 minus 4. B raised to power minus 9 minus 16 over 4, which is b raised to power minus 25 over 4. So what does that give us? Q, we were asked p plus 2q will be equal to minus 5 over 2 minus 5 over 2 plus 2 times minus 25 over 4, which is minus 5 over 2 minus 25 over 2, which is minus 30 over 2. And the answer is 15. And the answer is 15. So you can do it straightforward and you get your answer. We are going to simplify. Simplify 6 raised to power 2n plus 1 times 9 raised to power n times 4 raised to power 2 raised to 2n divided by 8 raised to power n times 2 raised to power n times 12 raised to power 2n. You can see some factors here, so it will make our job very easy. This one will be equal to 6 times 6 raised to the power 2n times 9 raised to the power n times 4 raised to the power 2n. Look at it. Here we have factor of 9. We have multiple of 9. So this will be 2 times 9 raised to the power n. Makes it very easy for us. We have 2 raised to the power n here. And we also have, let's make this one factor of 6 and 2. So this one will be 2 times 6 raised to the power 2n. Very interesting now. You can see. So we have 6 times 6 raised to the power 2n times 9 raised to the power n times 4 raised to the power 2n over 2 raised to the power n times 9 raised to the power n times 2 raised to the power n times 2 raised to the power 2n times 6 raised to the power 2n. So this one cancels this. This one cancels this. What again? If you look at it again, you can see that 6 times this will be 2 times 2 raised to the power 2n over 2 raised to the power n times 2 raised to the power n times 2 raised to the power 2n. And what does that give? 6 times 2 raised to the power 2n times 2 raised to the power 2n over 2 times 2 raised to the power 2 raised to the power n times 2 raised to the power n. That will be 2 raised to the power 2n times 2 raised to the power 2n. So this one cancels this. So our final answer is 6. Very easy and straightforward. Our final answer is 6. So the question says 27 raised by x plus 2 divided by 9 raised by x plus 1 is equal to 3 raised by 2x. Find x. So quickly we can do it like this. 3 raised to the power 3 into x plus 2 divided by 3 raised to the power 2 into x plus 1 is equal to 3 raised to the power 2x. So it will now be 3 raised to the power 3x plus 6 minus 2x minus 2 is equal to 3 raised to the power 2x. Equating the power. Equating the power. So we have this one as x plus 4 equals to 2x. So x, 2x minus x is equal to 4. X equals to 4. So our answer is 4. Very straightforward. So anytime you're having any problem, consult the rules. You make it will. You can't have any problem. Just know the basic of the thing. Anything raised to power this, give this, and that is all. Now let's move to the next section. Consult. In surds, you are trying to make sense out of irrational numbers, which are square roots of various numbers. We are trying to see how you can solve them, bring them to conclude answers on them with ease, so that there will be little or no approximations in getting our answers. There are levels in this, but everything is still simple. Everything is simple. When you look at surds as algebraic expression, where the root of a number is considered to be a term. Where the root of a number is considered to be a term. So let me show you what I mean. When we are talking of surds, we are dealing with square roots of several numbers. Like root 3, let me say root A, root B, etc. We can sometimes have something like this. Root 3 plus 4. Or 2 minus root x. We can have things like this. How do we solve it? I just said something else. When you look at each square root as a term like this one now, root 3, just within your mind, look at it as a root x. If you have it in the term or in another term, you can see it as b. Just look at it from this perspective. But where it's, varies from normal algebraic expression is the fact that you already know in your mind that root 3 times root 3 is equal to 3. So when you get to that, it gives you a rational number, and then you can stop thinking of it as a. This one now, you have root x times root x will be equal to x. So from that point, you will stop thinking of it as square of b or whatever. So that will make your understanding very good and clear. I want to show you something again. Assume you have something like this, root 3 times root 3 times root 3. We are going to have 3 root 3. So again, you are going to have it like, in your mind, please don't write it down like that. 3a, or this one now, you can have it root x times root x times root x. It's going to be x root x. So that is one thing I want you to have as basic understanding. It enhances your grabbing the whole thing. There is something. The first skill you need to have is how to convert a surd into full square root, or all the square roots into combination of a real number and an irrational number, that is square roots of another number. What I mean is this: the first thing you need to know is this. Assume you have a number like root of 27. When you want to convert it to combination of a number and the square root, you are going to have something like this: 3 times 3 times 3. You can see. So this 3, you can see it's going to be root 3 times root 3 times root 3. Root 3 times root 3 times root 3. So what does that give us? This one is going to be 3. It's going to be 3 root 3. Now if I have a number like that and I want to convert it to full square root, 3 root 3, it's going to give me this 3. I have to square it when it comes inside this square root sign, times the 3 here, and it's going to give me root of 27. These are the basic things that you need to be able to do. Once you can do this, every other thing is simple and will be clarified as we go along. Now let's look at another example. I think we have something like this: 5 root 3. 5 root 3. I have to convert it to full, everything to be fully under the square root sign. For this one to come in, I'm going to add it like this: 5 squared because this 5, once it enters the square root sign, under it, it's multi squared times 3, which is root of 75. Let's look at another number. Let's say I want to have like 72. I want to convert it to combination of rational number and square roots. It will be equal to 36 times 2, which will be equal to square root of 6 square of root of square 6 square times 2. At the end of the day, it's going to give me 6 root 2. That's the simplest way to explain it. So once you can do this, you can do so many things in surds. Let's look at expressions. When you have addition of surds, expression is addition of surds or subtraction. Like I said, you will gather the ones that have the same root and then you add. Let's look at this. We have root of 72 plus root of 18 plus root of 75 minus root of 300. What is that going to give us? We have this one to be root of 36 times 2 plus root of 9 times 2 plus root of 25 times 3 minus, let's see, this one is 100 times 3. So from this you learn about the addition and subtraction mainly. This one is going to give us 6 root 2 plus 3 root 2 plus 5 root 3. Okay, well, let me still simplify it further in case somebody has not gotten it to the stage. It's going to be root of 6 squared times 2 plus root of 3 squared times 2 plus root of 5 squared times 3 minus root of 10 squared times 3. So when this one comes out, it becomes ordinary 6, and it's going to give us 6 root 2 plus 3 root 2 plus 5 root 3 minus 10 root 3. So you see, this one, they have the same factor. These ones two are the same. They have the same terms. Sorry, they are like terms. So we have this one as 9 root 2 minus 5 root 3. So you can leave your answer in this way. Let's look at multiplication and division now. Now, if you have surds like this, root 3 times root 5, straight away is going to give us root of 15 straight away. When we have something like 4 root 3 times 3 root 5, what it will give us is we will multiply this ones here and this one separately. So it's going to give us 4 times 3 times root 3 times root 5. So it's going to be 12 root 15. Straight off, you get down 12 root 15. You get down with ease. Just like when you have, like in our algebra, when you have 4a times 3b, you know it's going to give you 12ab. That's how it will be. And that's what the mindset I want you to have. We can also have it sometimes like this. You can have it, let's say root of 72 times root of 8. That's okay. 72 times 8. 576. And you could have even broken it down from here. You could have said root of 72 times root of 8 is giving us root of 36 times 2 times root of 4 times 2. And you know that this one will give us 6 root 2 times 2 root 2. So, what does that give us? 12 root 4, which is 12 times 2, 24. So you can see the multiplication is very easy. The multiplication is very easy. But sometimes you can have expression which is combination of real number and square root like this. Expression like straight line linear equations. And you have to multiply them in the same way you multiply in our algebra, linear equations. That's the way you are going to do it. You know, when you have a plus b into c plus d, you take them in turns and you multiply. You say ac plus ad plus bc plus bd. So in the same way you will multiply. Let's look at one. In case you have something like 4 plus 2 root 3 into 5 minus 3 root 2. You are going to take them in turns, just like the normal. So this will be 4 times 5, 20. 4 times 12. So that will be 4 times this one, minus 12 root 2. This one is going to give us plus 10 root 3. And this one is going to give us minus 6 root 6. Can we simplify it further? I don't think so. So it's good like this. Unless you want to rearrange due to sign, you can say 20 plus 10 root 3 minus 12 root 2 minus 6 root 6. So with this, it has shown us that you can do our multiplication straight away in any, just like our normal linear equations, algebra. Division in surds is a bit technical. How? I start from the simple to a more involved one. When we have something like this, 3 over root of 5. When we want to divide, we do something we call rationalization. And how do we do that? We multiply the numerator and the denominator by this same number. That is root 5 over root 5. Root 5 over root 5. And what does that give us? It gives us 3 root 5 over 5. That's the rationalization process of this. So you can do so many division with this knowledge, in as much the denominator is just a single square root, a single number square root. If it is going to be sum or difference of two numbers, there's a different way we handle that one. Let's look at another one. We have, assume we have 4 minus root 5 divided by root 3. You know, if you are going to process this one, it might take very long and uneasy and be a bit stressful. But what do? We multiply numerator and denominator by root 3. So that this one will no longer be square root again and will look easier. So So what does that give us? It gives us 4 root 3 minus root 15 over 3. We can also have it like this. Let's look at another one. Let's say 10 plus root 5 over root of 5. Look at what it will become now. It's going to be 10 plus root 5 over root 5 times root 5 over root 5 times root 5 over root 5. What does that give us? So now we have 10 root 5 plus 5 over 5, and that will be 2 root 5 plus 1. You can see how easy it looks. It's better in this form than this format. When we have it as in, when we have the denominator as sum of a real number with square roots, with another square root, there is another process we use. We use this rationalization process, but instead of using the same number, we use what we call conjugates. We use what we call conjugate. Let's talk about conjugate first. Now let's talk about conjugate. You know, in our algebra, quadratic equations too, we have something like this. We have an expression like this: a plus b into a minus b. What does it give us? It gives us difference of two squares. It gives us difference of two squares. But in the terms of surds, in the situation of surds, if we have root a plus root b, we have root a minus root b. What will that give us? It's going to give us root of a squared minus root of b squared, which is a minus b. So in this instance, this one, let's call this one k, and this one is l. So k is conjugate of l, and l is conjugate of k. Let's look at another one now. Assuming a is a real number, so we have a plus root b. Its conjugate will be a minus root b. Let's multiply it out. Since we have it as a difference of two squares, it's going to be a squared minus b. That's all. This is the whole thing about in division when it involves real number and irrational number. I mean, when the denominator involves real number and irrational number. Let's look at an example. Now, to solve this one, we multiply the numerator and denominator by the conjugate of the denominator. So what does that give us? It's going to be 3 minus 2 root 5 over 2 minus 3 root 7 times 2 plus 3 root 7 over 2 plus 3 root 7. And what does that give us? Three into 2 plus 3 root 7 minus 2 root 5 into 2 plus 3 root 7. Please, the denominator, whenever you have it, you don't need to crack your brain again, please. Don't bother. So this one is going to be 2 squared minus 3 root 7 squared. So it's going to be 2 squared minus 3 root 7 all squared. Straight away. And then this one is going to give us 6 plus 9 root 7 minus 4 root 5 minus 6 root 35. This one is 4 minus 9 times 7, which is going to give us, if you look at this, there's nothing to simplify again. 6 plus 9 root 7 minus 4 root 5 minus 6 root 35 over, this one is 63, this one is 4 minus 59. That's the answer for that. That is the answer. Let's talk about squares of surds. How do we obtain the squares? It is by multiplying the surd by itself again and again. Like we have treated something like this before. Let's look at 3 root 7 squared. What does that give us? It's going to be 3 squared times root 7 squared. Since this one is 3 times root 7, you understand? 3 root 7 is equal to 3 times root of 7. So this one is going to be, so 3 root root 7 squared is 3 squared times root 7 squared, which is 9 times 7. That is 63. That's 63. So in the same way, we can have 7 root 3 squared. And that will be 7 squared times root 3 squared, which is going to be 49 times 3. That's going to be 7. 147. 147. We can also have something like this. 3 minus 2 root 5 squared. The same way you multiply out in the normal algebra, you can do it straight here. Either by saying 3 minus 2 root 5 bracket into 3 minus 2 root 5. You can do it as many times as the power you are asked to do it. So we can say 3 minus 2 root 5 into 3 minus 2 root 5. And that will give us 3 into 3 minus 2 root 5 minus 2 root 5 into 3 minus 2 root 5. And what does that give us? 9 minus 6 root 5 minus 6 root 5. So this one is plus 4 times 5 plus 20. At the end of the day, we are going to have 29 minus 12 root 5. 29 minus 12 root 5. You can also look at this trace from our knowledge of squares of a linear expression. Here we know that a plus b squared is equal to a squared plus b squared plus 2ab, or a minus b squared is equal to a squared plus b squared minus 2ab. All these expressions are very useful, not only in this space. We also have complex number and all these spaces. They are very useful there. So let's look straight into this. This one is going to be 9, or let me say 3 squared plus 2 root 5 squared minus 2 times 3 times 2 root 5. So you can see it makes our job very easy. 9. This one is 4 times 5 plus 20. 2 times 3 times 2 is 12. 29 minus 12 root 5. So you can see, if it is positive, if this is positive, that will be plus. So you can do it in, it can come in any form, and then you can find squares of your surds conveniently. You can also find square roots of some surds. Square roots of some surds. Find the square root of 21 plus 8 root 5. If you point with your calculator, you are going to get a certain figure, and then you can square root it again. But in this instance, we are not using that approximation formula. We are going to express it using our knowledge of the square of two numbers. Let's have it like this: 21 plus 8 root 5 is going to be a plus b all squared. And why did I am trying to explain something. It is going to be a plus b squared, but that a is going to be in surd form. So this will now be equal to square root of k plus square root of l all squared. I definitely introduce this so that your mind will be wide awake to know that, oh, it's the same thing like what we used to do. So let us expand this one, and this one is going to be, so this one, erase this from your mind, work from this now. Root of k squared plus root of l squared plus 2 into root of k times root of l. I believe you remember from a plus b squared. So this is going to be k plus l plus 2 root k l. When you now equate this to this, you equate this one to this, you will realize that the real numbers are k plus l and the rational number is 2 root k l. Therefore, we have k plus l to be equal to 21. 2 into root of k l is equal to 8 root 5. This one, we can work with this. Let us solve this further. So we have root of kl to be equal to 4 root 5, which is equal to root of 16 times 5, root of 8. Therefore, kl is equal to 8. You can see kl is equal to 8. From here, you can use any technique you prefer. I'm going to do it in two ways now. Let us make L to be equal to 80 over K and substitute into equation 1. Let's substitute this one in this equation. So we have K plus 80 over K is equal to 21. So multiplying through by K, we have K squared plus 80 is equal to 21K. So we have K squared minus 21K plus 80 is equal to 0. And then we have K squared minus 16K minus 5K plus 80 is equal to 0. So K into K minus 16 minus 5 into K minus 16. So when we solve further, we realize that K minus 5 into K minus 16 equals 0. So K equals to 5 or 16. And if we substitute back into this place, we realize that L is equal to 16 or 5. L is equal to 16 or 5. Now let's look at it from another angle. We realize that K plus L is equal to 21. KL is equal to 80. You can also say K plus L squared is equal to 21. No, yeah, 21 squared. So K squared, K plus L all squared minus 4 times 80 is equal to K minus L all squared. So this one is going to be 21 squared minus 4 times 80 is K minus L squared. So we have this one to be equal to 1, 2, 1. Therefore, K minus L is equal to 11. Is equal to 11. And K plus L is equal to 21. So if we add this together, 2K is equal to 32. K is equal to 16. Or 2L is equal to 10. L is equal to 5. So the square root of this expression, that is 21 plus 8 root 5 is equal to root of 16 plus root of 5, or square root of 21 plus 8 root 5 is equal to root of 16 plus root of 5, which is equal to 4 plus root of 5. So as an exercise, you can square this to know if it will give you back that answer. So this is the major thing that we encounter in surds, and it has helped us in trigonometry and so many other places where we would have seen things as difficult. Now let's look at this question. We have n plus root 3 into 1 minus root 3 squared equals to 6 minus root 3. So we have this n plus root 3 into 1 minus root 3 all squared is equal to 6 minus 2 root 3. Let's work this out. It's going to be m plus root 3. From the other time, you know that this one is going to be 1 plus root 3 squared minus 2 into 1 root 3 equal to 6 minus 2 root 3. So we have m plus root 3 into 4 minus 2 root 3 is equal to 6 minus 2 root 3. Therefore, m plus root 3 is equal to 2 into 3 minus root 3 over 2 into 2 minus root 3. So this one cancels this. Multiply by the conjugate of the denominator. 2 plus root 3, 2 plus root 3. And that gives 6 plus 3 root 3 minus 2 root 3 minus 3 over 4 minus 3. Please, I want you to get this thing straight. I multiply this with each of these terms, and minus 3 with each of these terms. This one is 2 squared minus 3 squared. That gives me this straight up. So this one at the end of the from here, you see that 6 minus 3 is equal to 3. Root 3 root 3 minus 2 root 3 is equal to plus root 3. And 4 minus 3 is equal to 1. So n plus root 3 is equal to 3 plus root 3. So subtracting root 3 from both sides, we have n equals to 3. So our answer is n equals to 3. Now we have this. If k, find k. If k over root 3 over plus root 2 is equal to k root 3 minus 2. We have this. K over root 3 plus root 2 is equal to k root 3 minus 2. Therefore, let's rationalize this one here. We have k. So this will now be k into root 3 minus root 2 over 3 minus 2. What will be k root 3 minus 2? You see? So we have k root 3 minus k root 2 is equal to k root 3 minus 2. So when you subtract k root 3 from both sides, you are going to have minus k root 2 is equal to minus 2. Therefore, dividing both sides by minus root 2, I have k is equal to minus 2 over minus root 2. K is equal to root of 2. So our k is root 2. Our k is root 2. Very easy and straightforward. So once you know how to start doing it, you get your answer fast. Now let's look at this one. Quick one. Root 12 minus root 3 over root 12 plus root 3. What is that going to give us? It's going to give us, let's divide denominator and numerator by root 3. So this is going to be root 4 minus 1 into root 4 plus 1. So what does that give? This one is 2 minus 1 all over 2 plus 1. 1 over 3. So that gives us 1 over 3.